Hey Mackenzie, this is the video that you asked for, so hopefully it helps you out. Now I'm going to start with the very basics, okay? This is called a Cartesian coordinate system. It was made by a man named Rene Descartes, and hence the name Cartesian. Descartes comes from there, okay? Now, it is very important. So many kids are so lazy with this. I don't think they realize the importance. You need to label the x-axis, the y-axis, and the origin of every graph that you make. Every single one. Furthermore, you should tell me what you're counting by. Don't just assume it's 1. Okay? So I'm going to mark each first one with 1. Now, if you want, you can label points, and I'll get more to that. Now, it's alphabetical on purpose. You have an x-coordinate, and you have a y-coordinate. You have to move in the x direction first, and then you move in the y direction. Okay? X before Y, just like in the end of the alphabet. You'll hear me say to kids when they do Y before X, I'll say, do you know your alphabet? Because I'm trying to make an impact on them. Of course they know their alphabet. I know they know it, but I'm trying to get across to them that you have to do the X coordinate first. So if I had the point, say 5, -2, okay? From the origin, by the way, the coordinates of the origin are 0, 0. That's why it's the origin. It's considered like a beginning. It's not really the beginning of the graph. The graph has no beginning. It's infinite in all directions. But these are the 0, 0 coordinates, so it's where you start counting from. You begin from there. So I'm going to move 1, 2, 3, 4, 5 in the x direction, and then down 2 in the y direction. Why down 2? Because it said -2. That's the point 5, -2. Okay, now if I had the point, say, -7, 3, well, again, I'd start at the origin, I'd move -7 in the x direction, or 7 to the left. 1, 2, 3, 4, 5, 6, 7, and then +3 in the y direction, so 1, 2, 3. Okay, so that would be the point -7, 3. The most common mistake kids make are they go y before x. It's never that. It's always x before y. Now, some important things to note about this before we get to an input-output table. This graph, these Cartesian coordinate planes, are broken up into 4 quadrants. Quadrant 1 is here, and then you go counterclockwise. Quadrant 2 is here. Quadrant 3 is the lower left corner, and then quadrant 4 is here. They usually use Roman numerals to denote them. This is 1, 2, 3. A V is 5 in Roman numerals. Putting a number like 1 in front of the V means 5 minus 1. It means you subtract. That's why the 4 looks that way. Now, when you're here, in quadrant 1, you have a positive x coordinate and a positive y coordinate. So if I was to graph the point 3, 2, 1, 2, 3, 1, 2, it would end up in the first quadrant. Okay, no, it's not the point 2, 3. 2, 3 would be up here, right? Because I'd go 2 in the x direction and then 3 in the y direction. It's not the same thing. All right, the second quadrant, the x coordinate is always negative. The y coordinate is always positive. If I'm in the third quadrant, they're both negative. Okay, and in the fourth quadrant, x is positive, but y is negative. So those are just some things you want to take some notes on, practice, memorize, maybe make some flashcards out of, because I'm expecting you guys to already know how to do this. I'm so glad you asked and said, hey, I have trouble with it, so we know we have a gap in our learning, so let's work together to close that gap so it's not a hindrance. Now it's up to you to practice a little bit. Okay, so we've got our coordinate system here. Now let's say we had a simple equation, a linear equation, y equals 1/2 x minus 3. Okay, I've talked in class about how it's silly just to pick 0, 1, and 2 every single time. In fact, on this one, I'm definitely going to pick 0. 0 makes sense. I'm not going to pick 1 because I got to take half of 1, and I don't want to graph a half a point or half a coordinate. So I'm going to pick 2. And I'll tell you what, I'll pick -2 just to see what's happening if x is negative. All right, so now I'm going to do my math, and I'm going to do y equals 1/2 times -2 minus 3. Well, 1/2 times -2 should be -1, minus 3 should be -4. So this will get me -4 right here. Okay. Now, don't you ever erase work. I just want to be able to fit it all on my graph. Okay. So let's see here. The second one, y is 0. Now, this one I normally don't show all the work for because I can do it in my head. I don't want to leave you guessing on anything. So I'm going to go ahead and show all the baby steps. 1/2 times 0 would be 0. 0 minus 3 would be -3. Okay. And then when I put 2 in, it's going to be very much the same thing. Maybe I can save myself a little rewriting problem here. Okay. When I put 2 in, I'm going to get 1/2 of 2 is 1. 1 minus 3 will be -2. All right, so now I go to graph these. If you don't realize it, this is the point -2, -4. This is the point 0, -3. And this is the point 2, -2. So I'm going to plot all three of these points. Now remember, I always do the x-coordinate, then the y-coordinate. So I go to the origin, and I go 2 in the negative x direction, and then I go 4 in the negative y direction. So there's my first point. That is the point -2, -4. Okay, and I guess I forgot to label what I'm counting by. So I should put a 1 there, and I'll put a 1 there. All right, the second point. I'm at the origin. I'm not going to move in the x direction because it says 0 for the x-coordinate. So it's going to be on the y-axis. Then I have to move down 3 in the y direction because it's a -3. 1, 2, 3, and there is a mistake there. I counted wrong, didn't I? I sure did. 2, -4 should be down here. There we go. Easily fixed. Okay, I'm not sure why I chose green there. I think it just fooled me, the color. All right, finally, the third point is 2, -2. So I go 2 in the x direction from the origin and then down 2 in the y direction. Now, you know that this line has an infinite number of points. I'm showing 3 of them. They all line up perfect. Okay, I'll change the color of that line here so you can see it better. They all line up perfectly. Go a little thinner, we'll make it orange, and put an arrowhead on the other end. Okay, I don't know if you're able to tell, but if you look, I go up 1 over 2, up 1 over 2, look at that, I hit another point. If I put 1, 2, 3, 4, if I put 4 into my input-output table, I guarantee you I'm going to get the point negative, or the y-coordinate of -1. Yeah, because remember, the points are the solutions to the line. I go up 1 over 2. It's off a little bit, but it's more human error. I made this graph paper myself on here, and those squares aren't perfect squares. But if I put 5 in, no, not 5, silly me, 6. If I put 6 in, I'm telling you I'm going to get 0 out. I guarantee that this is going to happen. Okay? So that's the basics of graphing. Now, if you have an unusual one, like an absolute value graph or a quadratic or something like that, okay? In class, I've told you to not just use 1, 2, 3. I've told you to go ahead and use, -2, -1, 0, and 1. Okay? So you've got to be careful with your math. If you do the order of operations wrong or you make some integer error, then of course you're going to get the wrong answer. And remember that you should use parentheses when you substitute in. Okay, so I'm going to put -2, -1, 0, 1, and 2 in. Okay, and I'm counting by ones on this. All right, so if I put negative 2 in, y is going to equal negative 2 squared minus 4. Well, this will be 4 minus 4, which is 0. So negative 2, 0 will be on this graph. So I go negative 2 in the x direction, 0 in the y. There it is, negative 2, 0. Okay, negative 2, 0. Okay, if I put negative 1 in, I get negative 1 squared minus 4, and that should equal negative 3, because this part will be 1, and 1 minus 4 is negative 3. So that means negative 1 goes to negative 3. So negative 1, go to negative 3, right there. Okay. If I put 0 in, I'm going to get y equals 0 squared minus 4. That should just come out to be negative 4. Okay. Now, a nice thing about parabolas and quadratics is that they're symmetrical. Watch what's going to happen. I'm going to put 1 in, and I should get negative 3 out. Hopefully you can verify that. Okay, and then finally I've got to put 2 in, and I'll get 2 squared minus 4, and that would be 4 minus 4, which of course is 0. And so now I've got this perfect symmetry going on. All right, and so my graph is going to look like this. It's tricky to draw parabolas on my airliner, so I do the best I can. Okay, it's not a V, it's a U. It's nice and round at the bottom, and I'm a little critical here. It should be hitting that point. Yeah, I'm having a hard time getting it to do that, but that's close enough for our purposes. You'll be able to draw it better with your freehand than I can with my airliner. All right, that's it for the video. I hope this helps you, buddy. And, you know, if I'm in school tomorrow, you can come on in and see me at Pride Time. If I'm not, come in Tuesday anyway. And let's just practice this, because this is such an important skill. And we're going to be going into some really heavy graphing on Tuesday. And we're going to stay with the heavy graphing for a while. All right, well, I hope you enjoy the rest of your weekend, buddy. I will talk to you later. Have a good night.